Good morning everybody. Myself Acharya Vishvendra, and today I am going to discuss a summary of the chapter Motion in a Straight Line. So let's begin with the summary. So this is the part of optimal physics program, and today I am going to discuss chapter summary. And this summary is from the chapter number 2, which is motion in a straight line. So let's begin with the chapter itself. So basically, motion in a straight line is about, first of all, position. Second thing is velocity. Third is acceleration. Fourth is time. Fifth is equation of motion. And sixth are the applications. So this is the topic in this particular chapter: position, velocity, acceleration, time, equation, and application. Only 6 topics are there. As far as position is concerned, so in the chapter position, in the topic position, there are, first thing is position vector, second thing is your displacement, and third thing is your distance. So first of all, let's begin with the position vector. So suppose this is x-axis, this is y-axis, and this is z-axis, and I have a point in space which has a coordinates x, y, z. So this is origin, and if you draw vector from O to B, this is my vector r, which is called the position vector of mass with respect to. So the first thing about position vector is that this is equal to point number 1, x into y cap plus y into j cap plus z into k cap. So this is how we can calculate the position vector. Second thing is, magnitude of this position vector or distance from origin is equal to root under x square plus y square plus z square. This is the second thing. Third thing is, if this position vector makes an angle alpha, beta, and gamma with the coordinate axis, then we have cos alpha is equals to x by r, cos beta is equals to y by r, and cos gamma is equals to z by r. Here, cos alpha, cos beta, cos gamma are called DCs of the position vector, or more specifically, the direction cosines of the position vector. So that is the third thing regarding the position vector. Now let's move to the next thing. So next one, now we have the fourth thing. If we square these terms, then cos square alpha plus cos square beta plus cos square gamma, that is equal to 1. And if we find sin square alpha plus sin square beta plus sin square gamma, that is equal to 2. All of these are the basic properties related to the position vector. So this is how we can analyze it. Now let's solve a question based on that suppose we are being given the point P and it has the coordinates 1, 1, 2, 1, 3, and the position vector with respect to origin is vector r. So the first sub question is we need to find vector r. So it is equal to I cap plus 2j cap plus I square. So you have seen that we have learned the concept. We learned 5 things regarding the position vector. Now let's do one thing. In the sixth part, let's apply all of what we have learned during step 1 to step 5. So the point is, given it has coordinates 1, 2, 3. So the first question is the position vector with respect to origin. So that will be I cap plus 2j cap plus 3k cap, as we have done earlier. The first part. Second part is, if we are being asked the magnitude of this position vector or distance from origin, so this will be equal to root under 1 square plus 2 square plus 3 square, and after solution we get 1 plus 4 plus 9. So that will be equal to 14. It will be about 3.8 plus 4, square of 4 is 16. So it will be a bit less than that. So that will be around, let's say, 1 3.8 2.7 just like that, उसके आसपास होगा। तो यहाँ से आपने सेकंड ऑप्शन निकालेंगे। थर्ड इज अगर यहाँ से आपसे पूछे कि एंगल अल्फा है तो आपसे पूछे कि बताइए cos अल्फा क्या होगा। cos अल्फा इज x by r, x here is my 1 and r is root 14। तो यहाँ से आप सॉल्व करेंगे अल्फा आपका cos इनवर्स ऑफ 1 by root 14 है। सिमिलरली अगर आपसे पूछते हैं cos बीटा, so cos बीटा will be pi by r, आप सॉल्व करेंगे दैट विल बी 2 by root 14। सो बीटा यहाँ से आपका cos इनवर्स ऑफ 2 by root 14 आ जाएगा। Similarly, हम cos गामा फाइंड कर सकते हैं दैट विल बी z by r, so that will be 3 by root 14। तो यहाँ से गामा आपका cos इनवर्स ऑफ 3 by root 14 आ जाएगा। ये ही ऑप्शन होगी। F ऑप्शन में अगर हमसे पूछा है cos स्क्वायर अल्फा प्लस cos स्क्वायर बीटा प्लस cos स्क्वायर गामा, तो इसको अगर हम सिंपलीफाई करें तो दैट विल बी इक्वल टू 1। नेक्स्ट क्वेश्चन में आपसे पूछा है sin स्क्वायर अल्फा प्लस sin स्क्वायर बीटा प्लस sin स्क्वायर गामा, इसको आप सॉल्व करेंगे ये 2 आ जाएगा। So these are the various options for this। अब एक बार इसमें क्या करते हैं, क्वेश्चन में थोड़ा सा ट्विस्ट डालते हैं, प्लेन चेंज करते हैं। मान लीजिए आपको केवल xy प्लेन में दिया है एंड पार्टिकुलर कोऑर्डिनेट्स लेट्स से 2, 3, तो यही पे पोजीशन वेक्टर है। मान लीजिए वेक्टर r, ये एंगल अल्फा है, ये एंगल बीटा है। पहला क्वेश्चन आपसे पूछे r वेक्टर, तो ये केवल 2y 3j हो जाएगा। मैग्नीट्यूड पूछा है, इसका तो स्क्वायर करके आप वेक्टर दीजिए 2 स्क्वायर 3 स्क्वायर, that will be 4 plus 9, that will be 30। नेक्स्ट आपसे अगर cos अल्फा पूछा है तो cos अल्फा आपका x by r आ जाएगा which is 3 by 30। और अगर cos बीटा पूछा है आपसे वो आपका y by r आ जाएगा that will be 3 by 40। तो ऐसे करके आप सिंपल क्वेश्चंस को एनालाइज कर सकते हैं। तो ये इसका फर्स्ट पार्ट था रिगार्डिंग फाइंडिंग द पोजीशन वेक्टर। नाउ लेट्स मूव टू द नेक्स्ट पॉइंट व्हिच इज फाइंडिंग डिस्प्लेसमेंट। सो this suppose a particle moves like this, it moves from point A to point B। so let's say this point has a position vector I, this point has a position vector RB। so vector joining initial and final point is called the displacement vector and it is nothing but RB minus I, so that is called the displacement vector। So simply you just need to find the difference of the two vectors। Take a question. Suppose a point starts from A. A has coordinates 2, 3, 4, and B has a coordinates let's say 3, minus 1, minus 2। So there are the 2 points. Point A has coordinates this, point B has coordinates this। So the first thing is we need to find vector, the position vector of A with respect to origin। So that will be 2i plus 3j plus 4k, very first thing। Second thing is you need to find position vector of B, so that is 3i minus j minus 2k, simply you can find that। Third thing we are being asked magnitude of position vector of B, so that will be root under 2 square plus 3 square plus 4 square। so if we add these up, 2 square is 4, this is 9, this is 16, so on solving we will get 28। Similarly, if we are being given to find position vector of B magnitude, so that will be equal to root under 3 square, 1 square, 2 square। 3 square here is 9, 1 square is 1, 2 square is 4, so that is going to be 40। Next question is we need to find displacement। So displacement is RB minus RA, and assume that B is the final point and A is the initial point। So here vector RB is your 3i minus j minus 2k minus of r as position vector 2y plus 3j plus 4। so if you solve this we have 3i minus 2y minus j minus 3j minus 4j minus 2 minus 4 minus 6k। so this is going to be the displacement vector, and in the next thing we need to find magnitude of displacement vector, so that will be root under 1 square plus 4 square plus 6 square, which will be 1 plus 16 plus 36, so which will be root 17 plus 36, which will be root 53, and root 53 will be about let's say 7.2। so in this way this is the magnitude of the displacement vector when the particle moves from point A to point B। so we have discussed certain points regarding the summary for motion in a straight line, so that's how things are going to work।